So I want to quickly revise few things, and then we'll get into the new portions. It's a distributed architecture, SD-WAN, and we have an orchestrator, vBond, NMS, vManage, um, the control plane, the vSmart, the data plane, which is a WAN edge. In between, we have a transport using which the WAN edges can communicate. See, P1 communication, a secured tunnel over a best path, and that is provided by this transport internet in the middle. So we may have multiple connections. One may be MPLS, one may be LTE, another may be internet. Using all this physical path, we want to overlay. We want the tunnel, which is also secured, which also has got more bandwidth, which also has got flexibility in inserting service policy and etc., for which we need this transport. WAN edge uses the transport in order to provide us the tunnel. So there are many components, there are many protocols involved in it, in which we are going to see in detail today. So when we talk about vSmart, vSmart is the brain, the controller. vSmart gets the knowledge of the topology. Yeah, you see the control plane, the middle, between the sides, we got a control plane, Cisco control plane, which is called vSmart. This vSmart learns about all the sites and the network behind the sites through OMP. That's one protocol. And we have IPsec to provide secured communication over the tunnel. We got BFD to measure the status of the link, to measure the jitter, the loss, the bandwidth over the link. And we have much more, we'll be seeing like T-log and so on. So between sites, we have tunnel. The tunnel runs both BFD and IPsec. But between the site, the WAN edge, and the vSmart, what we have is OMP. Right, so we need to focus on the SD-WAN inner work. This is where we need to begin. We have finished up to this level in our previous class. We have to focus on these protocols one after the other. Yep. So we have a protocol called Dtls or TLS. This is a tunneling protocol which secures the control plane that runs inside these tunnels. So inside this tunnel, you may run any protocol, but this tunnel basically runs this one as the important protocol inside the tunnel. There may be multiple protocols, as I said, like you may be running OMP. Earlier I said a protocol called OMP, Overlay Management Protocol, that uses this tunnel. and SNMP or netconf. But very basic important protocol that should be is DTLS and TLS. What is the necessity? Why do we need this protocol? When vSmart controller and vBond orchestrator and vManage NMS and WAN edge device wants to form a fabric, between all these devices, we can see this tunnel between the controller and the vBond and the NMS, means vManage, and also the WAN edge. We can see this DTLS TLS protocol. What is the purpose of this protocol? Why it is used in the tunnel? Or why it is called as DTLS TLS tunnel? We have even IPsec on it, but why we call DTLS TLS? See, you may have IPsec, you may not have IPsec. It's an optional one. You may have even GRE, but you don't have an option for this protocol, TLS and DTLS. So we can say the tunnel is DTLS TLS tunnel more than IPsec. The purpose is authentication. So between these NMS, vSmart, vBond, we need authentication. Our edge devices cannot go and talk to some vSmart and get the control plane. That would be dangerous. Our edge device need to get control plane information only from our vSmart. And our vSmart should import all the route policies only from our NMS we manage. And our WAN edges should get authenticated by vBond, and from where it receives the information about the vManage and vSmart. That is the procedure. That is zero touch membership. So this is for the authentication process. Now, some of these tunnels are permanent. Some of them are temporary. For example, the authentication that we have between the WAN edge and the vBond is temporary. Once the authentication is successful, it will be torn down, it will be removed. But the control plane tunnels between the vSmart controller and the WAN edge routers and the controller and the WAN edge, vManage will remain there, continuing, and it uses TLS. So DTLS is only where we have UDP is in between. For example, the vBond, the orchestrator, uses DTLS because the connections are mostly using UDP. So DTLS is what used. Datagram transport. TLS is between the other controllers and the WAN edge, except the vBond. Next, the next protocol is OMP, Overlay Management Protocol. So, as I said earlier, it is the vSmart, the one which is the control plane, makes all decisions related to routing. And not only that, even the access policy access policy for home, not for the underlay traffic, but for the overlay traffic. That's why we call this control plane, access policy for overlay routing domain. When I say overlay routing domain, we all should understand that we are talking about the tunnels, the virtual connection using the physical connection. So the physical network protocol are not involved here. The physical network may be running BGP, MPLS, this and that, but those things are not in our discussion here. We are talking about the tunnels, which is overlay, through which the packets are routed. So the tunnel topology is different. The overlay topology is different. The underlay physical topology is different. Now, on the overlay, the routing decisions are purely based on this OMP protocol information. vSmart controller makes all the decisions related to routing and access policy for the overlay routing domain. These informations are shared by OMP protocol. Or this information, how vSmart knows about the routes, it's all through OMP. So information comes from overlay management protocol. So it is the OMP information in vSmart determines the network topology. That this is the one which helps to calculate the best route in the overlay network for various destinations. And the routes that are determined in vSmart is now getting distributed to all WAN edge routers, based on which the packets will be forwarded to a next hop between the WAN edges. So, what sort of protocol is OMP? OMP is a TCP-based extendable control protocol. TCP-based protocol. TCP-based. Extendable, that's a very important word. Can be extended for various other services. Later on, when they do some advancement in SD-WAN technology, they can add more things in it. They can add IPv6. They can add many more things. That is why it is extendable protocol. OMP is a TCP-based extendable control plane protocol. It combines all the control plane functions under a single protocol umbrella. So, as I said, you can have IPv6 anytime, or you can add many more new functions under the single umbrella called OMP. And this OMP runs within this TLS and DTLS. It operates inside TLS, DTLS connection. So before OMP is established, it is TLS and DTLS. As we already know, it's the main thing, it's for authentication. So OMP runs only between the authenticated devices. So when vSmart controller uses OMP, it advertises different type of information which will be used by WAN edge devices for data plane connectivity and transport. So when a normal routing protocol advertises, we may see the exit interface we may see the next hop IP address and some metric along with it. But when an OMP advertises route information, you will see routes. You will see next hop IP address. Sorry, yeah, correct. Next hop information. Not only IP address, there are some colors, and we'll talk about that. So OMP carries route, next hop, encryption key, and then policy information. All right, based on which the path need to be taken over the overlay network. All right. So a simple word, if I need to say OMP exchanges control plane traffic, control plane information. All right. OMP and vSmart and Vantage. OMP is between vSmart and Vantage. OMP will or vSmart will not come in any situation to perform a data plane application traffic. As I said earlier some time back, it is like a route reflector in BGP. OMP also won't come in the path of data plane application traffic. OMP is only control plane traffic that determines the control plane. Right. So next is BFD. BFD is used between the edge routers only. Between SD-WAN edge routers. Between all sites, you want a secured connection. So every now and then, this BFD will be running between the WAN edge over the tunnel, overlay tunnel. Why? To measure the liveliness of the path, to measure the quality of the path. See, we will not simply blindly send a packet through some path. We will have some policy. I want less than 100 millisecond delay. How do you know which path has got less than 100 millisecond delay and zero loss? 10 millisecond latency. How do you know those things? This protocol will measure every now and then, it will measure the liveliness, the quality of the path. So when a link goes down or comes up, BFT is going to notify. See, BFT for many of you, it is like a protocol, runs with OSPF, BGP. See, that is underlay. This BFT is overlay. You should understand this. So this bidirectional forwarding failure detection, this is not only in the underlay we use, it is also now used over the tunnel to measure the liveliness, to measure the quality of the path. So when we have a policy to select a path between the WAN edge, saying I need a path which is less than 10 millisecond delay, BFT's information will be used by the WAN edge to determine the path. So how this works is the WAN edge router that is there in our SD-WAN fabric, they send hello packets. BFD hello packets. This hello packets helps to measure the path quality. So these packets are echoed back by the remote end which received the hello. That echo backing, the echo that comes back. I say hello and the echo comes back from my neighbor. That echo brings me the liveliness, the quality of the path. So by default, the WAN edge routers, every WAN edge routers can measure loss, latency, jitter of the data plane tunnels. So what if I don't have a policy? Even then, BFT will be up and running. See, I said, BFD helps to measure the quality of the path so that if I want to send some traffic via a tunnel which is less than 100 millisecond delay. Yep, I said that. But what if I don't have a policy? Do I need BFD? Uh, of course, yes. Even though you don't have a policy to provide the best path among many paths, the default best shortest path, BFT will be there. So BFT's job is always there, whether we have policy set in the vSmart controller or not. There is nothing to do to enable BFT. It is enabled by default, based on which the path is going to be determined. So the path characteristics are then performed automatically. As soon as the data tunnels are up, operational between the WAN edges, the health of the tunnel will be measured using this BFT. And now this BFT runs inside the IPsec tunnel. As we all know, between the WAN edges, we will have an IPsec tunnel, the Dtls, the OMP, and this BFT helps to choose one tunnel, and which is also an IPsec tunnel. So as soon as the secured connection is established with a remote WAN edge, this BFD will start working. Right. So you may have multiple IPsec tunnels. BFD will automatically run over each of these tunnels and it will start detecting. It will detect the loss on each tunnel, the latency, the delay, the jitter, the path failure, all these things. Now, next is the T-lock. The WAN edge routers, the endpoints, they want to send traffics to various destinations. They want to direct traffic to various destinations. But the destinations to reach, you may have multiple transport. These transport are what called as T-lock transport locations. T-log, transport locator, transport locator. See, we got multiple paths between WAN edge, between two sites. You have an MPLS connection, you have an internet connection. So you have two T-logs now. So if I have three different transport, then I'll have three T-logs. One for MPLS, another for the internet, another for LTE connection, a leased line. So for each, you will have a separate T-log, three T-logs. So what is this T-log? I said, you have three paths between the WAN edges, then you have three T-logs. What exactly it is? We can understand that it identifies the transport. That's one thing. Secondly, what we need to understand when we talk about T-log is T-log uses the overlay. The IPsec tunnel endpoints within this SD-WAN fabric. At the same time, it is the same T-log, the one which is providing you the abstraction layer of the underlay transport link. Understand? Repeating again. We just spoke like we have three paths between the sites. One is MPLS, other one is the internet, the other one is a leased line. What is this? What are these? These are physical layer, physical topology, the underlay. But we don't send traffic using underlay information. We use the overlay tunnels. So for these three physical paths, there is an identification given on the overlay path using which we are going to forward the traffic. That's why I said T-log creates an abstraction layer of the underlay transport link. And T-log accesses the abstraction layer for defining the IPsec tunnel endpoints using which our traffic is going to be forwarded. The SD-WAN overlay fabric. So on this abstraction layer, on this top layer, which is built with the help of underlay, a physical or private transport links, which can be MPLS or which can be internet or LTE, without worrying about any of this actual IP address, the transport IP address, we are able to move the packet between the WAN edges using T-logs. Please understand, this is the key of SD-WAN. We got a WAN edge device, WAN edge here, WAN edge here, and you got multiple connections, transports. Now this is physical actually. This is physical connections. Pen is a little weird today. I'll call transport 1, transport 2, transport 3. You got 3 different transports. Now, whether you have policy or not, the packet needs to take one of this path. What if this path, which is taken, gone down? It has to move to this path, a backup path. But the next stop address will not be same. The address on this link will be different in the underlay. Understand? In the underlay, these addresses are not same. You remember when we have multiple paths to IBGP router, we don't use the physical interface address to form neighbor. Why? If the physical link goes down, your neighborship will go down. So what we do, we use loopback interface to form neighbor. Likewise, the T-log informations are going to be used to identify the remote site. At the same time, to make this as the primary path and this as the backup path, a color is going to be used. So now we will understand what does it mean when we say the abstraction. T-log creates abstraction layer of the underlay transport link. So it is the T-log attachment point information that needs to be distributed between the WAN edges to determine the path between the sites, which is also advertised by the same OMP. OMP only advertises this information. So it's a job of OMP to register the T-log with vSmart controller. And then vSmart controller, it understands the topology, exchanges the T-log topology, and builds the SD-WAN fabric. So the SD-WAN fabric, maybe from full mesh. See these things, I think we have. Yep, DTLS, TLS we finished. YMP we finished. BFT we finished. See, this is what we are talking about. The T-log informations are distributed. It's the vSmart which is there. So you may have a full, like this. We may have a full mesh topology. Now vSmart knows the complete topology. What all things it knows? It knows the T-log means the tunnel endpoints, the transports that are available, the WAN IP address, as well as the overlay color to reach the tunnel. That's how vSmart can build a control plane for the WAN edge to use. So these are all the things that are now going to be seen inside the T-log. One is system IP. This is a persistent one. it helps to uniquely identify the device, not the interface. Like we used to identify the IVGP router using loopback address. Loopback address helps to identify the BGP peer. The system, it is not identifying an interface, but it identifies a remote router. Or if you take OSPF, the router ID in OSPF helps to identify OSPF running appliance, not the physical interface IP address. Sometimes the router ID will not be even a reachable address in OSPF. It is simply an ID. But here, the system IP is reachable, but the system IP is not identifying any interface, rather it identifies the device, the edge device. And then the color. As I said, we have multiple transports, underlay transport. This color helps to pick one transport as a primary and the other as a backup. You maybe MPLS as a primary and internet as a backup. So color is needed. What if the primary goes down? I have to use the path whose color is internet. Then it goes via the internet when the MPLS is down. So it is actually system IP. System ID is like a system IP. Same like a router ID. But in the overlay operation. Again, same like OSPF. I think few seconds before I say wrong. System ID also is same like OSPF router ID. Need not to be a reachable address. Doesn't need to be a reachable address. If it is reachable, is okay, but not necessary to be a reachable address. System ID is just an ID, same like OSPF router ID. It needs to sorry it needs to be in a 32-bit form, that schema, same like what we learned in OSPF router ID. So using this system ID only, the sites are easily recognized. Yeah. So system ID is not going to identify the circuit. It is simply going to it is simply going to help you identify a site, but not the transport between the site, not the circuit between the site. The circuits are associated, the connections, the different transports that we have are associated with the color. See, we have different colors. This is different color. This is purple, this is green color to reach sites. So it is the color that used to determine the type of circuit. So color is used to differentiate different transport like MPLS, internet, leased line. And also it's the same color that helps to tell us whether it's a public or private underlay network that we have. So the data plane tunnels are established across different colors. Means in our case, what is the underlay? Color means transport. As long as the transport is reachable, uh, I can reach via MPLS, I can reach via internet, I can reach via listler. As long as they are reachable, the data plane connection, the data plane tunnels can be established across different colors. They need to have a reachable T-log transport locator. So if you try configuring these things, you will see different type of color already predefined in SD-WAN. Yeah. Okay. Next is the domain ID. Is a logical grouping of WAN edge routers and the vSmart controller. What does it mean? See, there may be many SD-WAN fabric. How do you know I am talking to the fabric to which I belong to? This domain ID. The domain ID on the WAN edge, the domain ID on the vSmart will be same. So the WAN edge router can only connect to other vSmart controller in its own domain. So within the domain, they have full synchronization of route information among the vSmart controller and the WAN edge router. So an organization can use multiple network according to the business need. Now each business unit will have a separate domain ID. Because you have multiple SD-WAN fabric, each fabric need to be differentiated. The WAN edge of one fabric should not get synchronized with another business unit vSmart. To avoid that, we have this domain ID. So it's your, you may have a very big, large network across the map, across the globe, a big geographical area, or you may be having a small SD-WAN fabric within a data center. This domain ID helps you to synchronize with the right vSmart. Yeah. So it is the domain ID that helps to identify the fabric, the group of WAN edge and the vSmart, and it also helps to synchronize, summarize, aggregate, because they are identified with unique number. So aggregation is easy, grouping is easy. Okay, next is the site ID. Site ID is a unique identification that is given for the site in the SD-WAN overlay network. So if I have multiple WAN edge router, can we have multiple WAN edge router? Yes, you can have for redundancy. When we have multiple WAN edge routers, they belong to one single site. So a site ID must be same for those two routers, two WAN edge routers. The site ID is important for WAN edge router to be authenticated by the controllers. Yes, site ID is very important. to get authenticated by the controllers. Yes, please. Hmm. Hmm. Very correct. The vSmarts and the WAN edges will have a common domain ID. For one SD-WAN fabric, the domain ID will be same for all WAN edges and vSmart. But site ID will be different for each site. You will have a unique number. Now this site ID helps to uniquely identify, get authenticated by the controller. And if I have multiple WAN edges in a site, I just finished saying you can have multiple WAN edges in a site and they should have same site ID. Now, when the site ID is same, by default, IPsec tunnels are not formed between those devices. Repeating again. If the site ID is same, no IPsec tunnels are formed between those WAN edge that has got same site ID by default. So you need, this is the condition. If I make mistake in site ID, two sites having same site ID, then they won't form, there won't be tunnel between them. So IPsec is formed only between the WAN edge routers with different site ID. So the WAN edge router that have got same site ID, they will not share any TLog information. So they don't establish BFD tunnel. So site ID is very important. Every site needs to have a unique site ID. If you make mistake in that, no IPsec tunnel, no BFD tunnel, no TLog informations. So using the site ID, sites are identified. Using the site ID, the topology, the shape of the topology is determined. Yeah. So you can have a hub and spoke, or you can have full mesh. It depends on the site ID that we write the policy. The site with the multiple nodes, they will have same site ID. They don't form any IPsec between them because it's the same site. Within the same site, they have multiple WAN edges. So to avoid having IPsec tunnels, we use site ID. Site ID same, so no tunnels. Right. So you should be very careful when you choose a site ID. It should not be duplicate. The site ID is going to be used to shape the topology. It is going to be there in the policies. Right. Next is use cases in SD-WAN. Critical application SLA. Bandwidth augmenting. What is augmenting? Bandwidth increasing, you can say. Bandwidth increasing. Bandwidth, um, more bandwidth. Bandwidth improvement, bandwidth increasing, something like that. Augment means. So you can have SLAs for critical applications, service level agreement. You can have a special path for some traffics. You can increase the bandwidth. Can I increase more than what it is there in the physical? Uh, it was no. It was no earlier. But now with SD-WAN, I can combine the bandwidth of the internet and the bandwidth of MPLS. Boom. That is what this bandwidth augmenting. I can combine the bandwidth of MPLS transport and the internet transport and give it to the overlay tunnel so that the tunnel will have more bandwidth augmenting. Secure segmentation. Yep. So secured segmentation is like having a IPsec, having a VPN with firewalls in the middle. And those things are secured segmenting. Sorry, those things will not come under secure segmenting. Secure segmenting is like isolating the traffic. Secure segmenting, you see, like VLAN is a segment, VXLAN is a segment. Secured segmenting, isolating one traffic from the other. Next is regional secure parameter. A service chain you create between the WAN edge devices so that all communication between the WAN edge device goes through a firewall. Secure parameters. Direct internet access. See, there are a lot of black holes in the internet that delays the routing always, which can be avoided using SD-WAN. At last, the cloud on-ramp. Right. These are the things that we are going to go in depth in our next class, one by one. We'll see one example on each and understand how SD-WAN can provide all these things which is not available in the physical traditional network. Any question on today's delivery?